So Year 12 Maths Extension 2, I'm conscious of time here, so I will go through this pretty quickly, but there are some pretty significant changes. Proof. The notation throughout is a lot more formal. We're now using capital letters to denote statements. That's never in the previous syllabus, but it did appear in HSC exams, so it's good to get that clarification. The notation throughout for and, or, and negation, we're now using that in symbols rather than words. So it is clear that it's a lot more rigor, I guess, in the previous treatment. Down the bottom here, negation of statements is now explicitly included. The first one there, the negation of a negation, I think that's pretty obvious. The next one, known as De Morgan's laws, although the syllabus doesn't actually call it that, they're explicitly in now. And the last one here, that is the negation of an implication. I am personally so glad that they brought that up because to me, that result is not obvious at all. There's a lot more going on behind the scenes in terms of formal proof. So the fact that they've said that it is in the course, I'm glad they said it. If anyone knows, the 2020 HSC question 8 multiple choice in extension 2, that was the first year of the new syllabus, and there's an absolute ripper of a question there that involves negation of an implication, and I dare say that took a lot of students by surprise. So the official inclusion now, I think it kind of in a way creates a level playing field in the sense that we know we're covering it. Next slide, please. Illustrations of proof are largely the same. That's where your proof by contradiction, contrapositive, that kind of thing is all in there. In inequalities, explicit inclusion of the squeeze theorem, that's already in the Cambridge text. And if you look through the last 30 odd years of HSC questions in extension 2, there are so many beautiful questions that actually do use the squeeze theorem. And it's just kind of relying on intuition there, but now it's explicitly covered. Under induction, I mentioned this before, but n not increasing by 1 is no longer explicitly extension 2. That can appear in extension 1. So I guess that's a removal, but it could still appear in extension 2. Extension 1 induction was restricted to sums and divisibility. Extension 2 is far more broad, but largely I don't think there are many changes to the previous syllabus. Next slide, please. Under vectors, as I mentioned, vectors in 3D, that has now moved to extension 1. Vector equations of lines, we're now defining skew lines. That's actually already in Cambridge text. A very subtle point. The previous syllabus had a content point about identifying whether or not intersecting lines are intersecting lines are perpendicular, I should say. That point is now removed. So it's possible now to have a situation where you've got two lines that have perpendicular direction vectors, but they're not perpendicular because they don't intersect. And that's quite subtle, so just be aware of that. Under vectors and geometry, the Cauchy-Schwarz inequality for vectors, that is now explicitly in the syllabus. Again, I'm very happy that they mentioned that because it's a natural idea that appears if you're looking at the dot product. And I've got their question 16A part 2 from the 2021 HSC is just straight up the Cauchy-Schwarz inequality. So again, it's good to know that the kind of playing field has been leveled there. We've all seen it. Proofs of geometric results in 2 and 3 dimensions, that's moved, well, the 2D part has moved from extension 1. I just wanted to give a shout out there to the teaching advice section because there's a very long list of contexts that you can use for those geometric result proofs. Most of them are in our book, but just be aware that is a very useful list to look through. Next slide, please. So under complex numbers, classifying numbers into their sets, natural, integers, rationals, reals, complex. That's now specifically in the syllabus. The teaching advice basically suggests not to go near the ambiguity regarding the inclusion of 0 in the natural numbers. But in the teaching advice, they've used Z plus and Z plus with the union of 0 as a way to kind of avoid that ambiguity there. Moving down, explicit mention of the geometry of the nth root of plus or minus 1 is now in the syllabus. The previous syllabus only mentioned roots of unity, so now we've got roots of minus 1 as well in that same depth. A large change overall, which might be controversial for me to say, but I'm happy about it, is that Euler's form has been removed. Next slide, please. So I mentioned this earlier, but products to sums moved from extension 1, T formula moved from extension 1, and I think a really important point that could potentially be overlooked is that these content points appear in the integration section of the extension 2 syllabus, but there are plenty of things that they have to do with them other than integrate. So the examples I've got here, we're solving a trig equation using a reversal of the products of sums results. And the next one, they're effectively using a t substitution, and you've got to check for pi, which turns out pi is a solution there. It's not going to pop up. Those integrals right at the bottom there as well, involving products to sums, they're explicitly in the syllabus now, but all that stuff's already in the Cambridge book. Next slide, please. Partial fractions decomposition. We've got perfect square denominators have been included now. That's not in or out, it's vague, but it's worth mentioning that that didn't appear at all in the last 6 years worth of HSC papers. So again, good to get that clarity. The next content point is a syllabus. Sorry, it's an example from the syllabus, and I just wanted to bring it up here because it's just partial fractions, but I wanted to mention it because it's really annoying. If you have a look at how that quadratic factorizes, that's an example from the syllabus. So we do want to make them do annoying questions, basically, is what I'm getting at. So there's nice, easy cases, but then we've got stuff like that to deal with as well. The teaching considerations mention that we're not using these kind of integrals from the old pre-2017 standard integral sheet. I've heard a lot of people say, oh, who cares? They're just random integrals. I did just want to bring up, because most people think, who cares about these integrals? In mechanics, if you have a falling object, resistance proportional to the square of speed, if you want to find a relationship between x and t, the easiest way to do it is to reduce an integral to the one I've got there at the bottom, the integral of du over root u squared plus 1, using a substitution, and from there you just invoke one of those results. So it's probably not going to appear in an HSC. I think they've made it very clear that they don't expect students to see it. But I bet you if it ever does, that would be the context in which it pops up. That would be my prediction. Those integrals appear in our books twice. Once in a question where it says differentiate, hence integrate, and then another one where they're using a trig substitution, but certainly it's not something we want them to memorize. Next slide, please. Under mechanics, forces, as I mentioned, removed from extension 1, now explicitly in extension 2. Simple harmonic motion, we've got a new form for displacement there alongside the old ones. We've also got this result for v squared that's in the syllabus, and it's also on the new reference sheet. I'm very happy about that. Something that really baffled me a few years ago. There's a question, 13D in the 2021 HSC. My reading of the question is that you're actually meant to derive the results. If you actually open up the HSC marking guidelines, they quote this result for v squared and then sub into it. And I would have thought that that was a big no-no. So I'm very glad that they've included that now and given us some clarity that that's actually fair game to quote that result. Under modeling motions without resistance, pulley problems are specifically included. I was terrified when I first saw a pulley pop up in the first year of the HSC, but there it was. Again, good to get that clarity. I'll talk a little bit more about pulleys on the next slide. Smooth inclined plane problems are also specifically included. And there was a bit of a ninja edit to the syllabus 2 months ago today. It used to say that you solve those problems by resolving forces parallel and perpendicular to the plane, and now it just says resolving forces, which I think is quite sensible because sometimes it's just easier to do it vertically and horizontally. So yeah, just a bit of a ninja edit there, but it is kind of good to know that that happened. All of those concepts did appear in the last 6 years of HSC, but I think they were perhaps a surprise when they did pop up, but now they won't be. Next slide, please. Rectilinear resisted motion. Just the sigma notation there for the sum of all forces acting on a particle is new. There's a content point here that explicitly removes pulley problems from a situation where they experience resisted motion. And as I mentioned, 2020 extension 2 HSC 16A, it actually had a pulley problem where you had two masses and each mass was also experiencing air resistance. So that was a bit of a tricky problem for sure. But according to the new syllabus, that is not fair game anymore. And perhaps I'm being too pedantic here, but that same syllabus content point that excludes pulleys from resisted motion does not exclude inclined planes. So just keep an eye on that. I would expect that something moving down a plane experiencing friction, that to me is fair game. Down the bottom, projectiles and resisted motion, the removal of overlap with the extension 1 is that's good. Resistance of a projectile moving in 2 dimensions is now specifically proportional to speed rather than the second power of speed, which actually has a set of DEs that can't be solved, so that's sensible to remove that. And there's a new content point about comparing the path of a projectile with and without resistance as well. Next slide, please. All right, so it's all pretty sensible in the sense that Extension 2, it's its own standalone book. Complex numbers are split into 2 chapters, as is our current textbook. And the new edition really is further integration has been split into Chapter 5, Trig Identities, and then Chapter 6, Integration. Chapter 5 is 2 exercises. Very short chapter, but the first one covers products to sums, and the second covers T results, and all of the problems in those don't involve integration. So as I mentioned, they're just using those results to solve some of those identity style problems, solving equations, stuff like that, but they're not actually a part of integration, even though they're in the integration syllabus. Next slide, please. So this is my last slide, but I just want to talk about some of the features in the Extension 2 book. As with the previous textbooks, there's a big range of problems graded into foundation, development, enrichment, a whole lot of new problems here to reflect the new style of the syllabus and the language that they're using. Detailed examples with the solutions throughout, and as we've mentioned, there's a video for each worked example as well. This is a quite rigorous maths book in the sense that the maths is, this will stand someone in good stead as they go to university and study maths there. There's nothing in this book that they're going to come across in university and be like, oh, that was wrong. That wasn't quite right. The language is precise, but at the same time, it caters to all learners in the sense that we've got some solid foundation problems there for them to work on. A rigorous approach to mathematics. Dave Sadler and Derek Ward, that is really their bread and butter. They really want this to be a solid maths book, and I am actually really proud of what this is and what is kind of going to be out there. A lot of extra questions have also been written, and those extra questions a lot of the time are inspired by past HSC problems that have a bit of maybe a weird context or just a bit more explorative in nature. That seemed quite unfamiliar. So we've kind of made an effort to look at those previous papers and try and write some problems that are maybe not quite what you would ordinarily expect.